Hi. We're going to go through the batteries presentation here real fast. I'm going to skip through a bunch of this stuff and just hit the high points, just so you know. First step is always safety glasses, safety PPE gear. We've been hearing a lot about it on the news. No exceptions, got to stick around them. Also realize that battery acid can be bad. I mean, it's not like the Aliens movie where the alien blood eats through the floor. It's not that acidic. It's pretty acidic. I mean, you get some on your jeans. You wash your jeans a couple of times, it will leave a hole. Can you get it on your hands? Yeah, it's not a big, huge deal. Although you don't want it on your hands for any length of time. I mean, it will. I mean, if you get some on your clothes, like your pants, yeah, you really got to change your pants. You certainly don't want that to sit on the what do you call it? The personal regions, if you get what I'm saying. All right. And then just wash your hands. Don't go eating anything, don't, anyways. So what's inside a battery? Well, it's pretty simple. There are 6 different cells. Think of it as kind of like, a AA battery or a AAA battery. There's 6 of them that are separated inside a plastic case. So these are 2.1 volts per cell. 6 cells, that's 12.6 volts. So a fully charged automotive battery is not 12 volts, it's 12.6 volts. Okie dokie. They're connected in series with each other. So end to end, one path for all. If one of the cells goes bad, it can drag down the entire battery. And all it is 2 dissimilar metals in an electrolyte, which is slightly acidic. Is it real acidic? No, it's not even going to open a drain on you. And it's got a hard plastic case, hopefully. There's different external differences, like the terminals themselves. We got top posts and side posts. Typically, the most common one in automotive at this point is a top post. Excuse me. The side post, that's typically older style GM, but they got rid of these a long time ago. I'm sure you've seen them. And then there's the L terminal. Pretty much that's heavy equipment. That's lawnmowers, motorcycles, that kind of stuff. Then we also have physical size. Usually that's determined by a group number. Group number is just one of the ways that they categorize them, like a 27 group or a 45 group or something. And that tells you a bunch of stuff about the physical characteristics of the battery, how big it is, how tall it is, how wide it is, how deep it is, which side negative and positive terminals are on. We'll cover more of that when we get out in the shop. Some will have removable caps, and we'll talk about that when we get out in the shop too. We got cold cranking amps, reserve capacity, and ampere hour. They're just different ways to look at a battery's capacity. Cold cranking amps deliver a specific current at a low temperature, which is 0 degrees, 30 seconds, without having terminal voltage fall below 7.2. That's cold cranking amps. This is the one we normally use. This is the one that we look for. It is listed as CCA. Okay. We got cranking amps. Now, this gets confused a lot in advertising and with people. CCA is a different type of rating. It's calculated at a higher temperature. Instead of being at 0 degrees, it's at 32 degrees, which is a higher temperature. I don't know why I'm explaining that to you. It's a higher temperature. So we can get there, and there's a formula for figuring out how to get CA into CCA, but just you got to watch it, because if it rates something that's 1,000 cold cranking amps, and then a different battery has the same rating of 1,000 cranking amps, realize they're not the same thing. The one that's listed as 1,000 cold cranking amps is a better battery. It's marketing. And then we got reserve capacity. This is used quite a lot in Europe. It's not used around here. It's not used in the United States. No, it's not used in Illinois. And it's how many minutes the vehicle can still be driven after the charging system has failed. So charging alternator has failed, all of the juice to run the battery is sucked, or all of the juice to run the car is sucked out of the battery. And if we look at a constant load, a constant current draw of 25 amps, which is, typical car driving along at night with the headlights on and all the engine management stuff on, not the blower motor, not the radio, not the wipers, just that is about 25 amps. It's how long would it last before the terminal voltage, the voltage of the battery, reaches 10.5 volts. That's typically where a car will stop running in terms of voltage. It doesn't get enough voltage, it stops running. About 10 volts. Then ampere hour. And this is how long it can supply a specific amount of current, right, for 20 hours. So this is a much longer time. It's really not used around here, but some batteries do have this rating on them. It's ampere hour. I'll leave this up. You can just write that stuff down. So how does it work? Well, quite honestly, battery just used to get it started. Once it's started, the engine supplies the alternator supplies the current to run the car. Now, so the battery is just used at the beginning. The secondary function of the battery, which is equally important that most people don't understand, is it has a stabilizing voltage on the vehicle. Modern vehicles, computerized vehicles today, they run on this electricity, and it needs to be stable. We start moving that voltage around, if it's not stable, well, then that can be an issue for drivability and fuels and emissions. Maintenance. Well, quite honestly, not all batteries are maintenance free. Probably the best thing you can do for a battery is just maintain it a little bit, and it doesn't take very much. You get a longer life battery and trouble-free starting. We're just coming out of the winter. Some batteries, if we kept them maintained, it wouldn't be that big of a deal. We will cover this battery maintenance out in the shop. What's needed? Well, honestly, cleaning the battery off. We'll talk about these, some of these things. If we don't have clean posts, it can, lead to poor electrical contacts, which results in the battery not keeping charge or not releasing its charge, not stabilizing the voltage. And then we also have the dirt. Condensation, moisture on the battery collects dirt. And this moisture and this dirt can actually cause an electrical drain. This is the important little bit. This current can flow across between the positive and negative terminals through the dirt. So just keeping the top of the battery clean is a huge deal. I'll show you this. And then we check the starting and charging system as well, which I'll show you how to do that as well. Not today, when we add starting, later. All right. On some batteries, we can actually check the electrolyte level in it. We only add distilled water. Regardless of what YouTube says, we only use distilled water. Now, what can I clean my battery with? Well, there's special cleaners and special formulated cleaners, but quite honestly, baking soda and water works just fine. You probably got baking soda in your refrigerator, to suck up that smell of that lasagna from last week or whatever you got in your refrigerator now. But quite honestly, that works great. Now, you do have to be really careful with this stuff. We can't let this the baking soda and water neutralizes acid, which is great, except if it gets inside the battery, into the electrolyte, it will neutralize that. And what do we end up with? Dead battery. Batteries can explode. Yeah, baby, they can. And this is actually the picture of a battery that I blew up. Honestly, here is the important bit. A fully charged battery isn't dangerous. It's the dead battery that's dangerous. Dead batteries release the sulfuric acid, the hydrogen gas, which that's explosive. Okay? Dead batteries are the dangerous batteries. Batteries that you're jumping, batteries that, those are the ones you got to watch out for. Fully charged battery, as long as you don't cross the terminals, you're good. But a dead battery, if you're trying to charge it up, or if you have a dead battery in your car and you jump it and it runs and you drive it, that battery under the hood can gas. This particular battery got blown up by me. Didn't realize, yeah, it was an issue. Also trashed the car. Anyways, so what precautions can be taken? Well, they're pretty simple. Number one is wear your safety glasses. And then we always disconnect the battery when we're working on doing any electrical work. Unless we have to, take voltage readings while, then we have to leave it connected. Also, here, we disconnect the negative terminal first. Because if we accidentally touch the wrench that we're using to disconnect the terminal to the body of the car, negative and negative isn't going to cause any issues. But if I'm disconnecting the positive and I short it out, well, that's going to create a short, and that can do some major damage. Battery chargers. This is actually pretty simple. Make sure the battery charger is off before you connect it. Connect the battery first. Observe the polarity. Red is positive, black to negative, and then the last step is you plug in the charger. I don't want any sparks around a battery that I'm charging. Why? Well, because it's dead. And what did I say? A dead battery is dangerous battery. And then we got to watch it. Most battery chargers that we have now in shops and stuff are extremely smart. They're not going to overcharge the battery. But older battery chargers, yeah, they will put enough current in that battery and keep on putting it in until it cooks. And then, there you go. Yeah, well, if you're gonna jump a car, you gotta, be really careful with it. We can cause some significant damage to the car if the connections are reversed, or we do this wrong. Yeah, absolutely, big, huge problems. So look. I'm all I'm doing is just, I'm going to put this up here and stop spinning. Here's the proper procedure for hooking it up. So then my question becomes, what do you do after that? Do you start the good car and then start the bad car? That's what I see most people doing. Well, therein lies the fault. That's the problem. Don't do that. You connect the two cars together. Then you try to start the bad car. It should start. If it doesn't start, you probably have bigger problems than just a jump start. Battery's junk, the starter is bad, something else. We generally do not have the good car running. The alternator in the good car is typically, especially a modern vehicle, is just not big enough to cover a fully flattened battery. You can damage stuff. So we initially try to start it, the bad car. If it doesn't start, we shut it off. We can start the good car and let it run for a couple of minutes, and then turn off the good car and try the bad car again. Get what I'm saying? No. I really don't want to go through all of this. Okay, but I'm just going to leave it up here for a second so you can, write down any notes you need. But just realize it's two dissimilar metals. And as it starts to discharge, the two plates, the positive and negative plates, which are dissimilar, start to become more and more similar. So they end up being exactly the same. And the acidic compounds of the electrolyte, it actually becomes more and more water. Does that make sense? So it's less and less, as the battery's discharging, it's less and less acidic, and it's more and more water. Anyways, all right. So, and then charging is just the opposite. So all it does is just force electrons back through the negative and positive plates, which in turn forces the electrolyte to become more and more acidic. It's chemistry, man. Science, guys. So these maintenance-free batteries you see, they just have, you know, some additional properties. They're vented a little differently so that we don't lose any of the electrolyte in them. And they have some antimony in the grids that helps, you know, uh, uh, give it a much longer life. So a lot of these guys are sealed and you can't get into them. I'd rather have one that wasn't maintenance free, FYI. Testing specific gravity state of charge. I'm going to just kind of blow through this specific gravity stuff. Nobody uses it anymore. Open circuit voltage. This is absolutely something you could do at your house. Okay? As long as you got a meter. You measure the voltage on a battery that's been sitting for a while. You know, if it has been, car's been running for, you know, any length of time, you're going to get a high surface charge. So you turn on the headlights or something, then knock the surface charge off, or do this test in the morning, all the accessories off, doors closed, headlights off, and you just hook up the meter to it. A fully charged battery is 2.6 volts. A completely dead battery has a voltage of 12 volts. So what are we talking? We're talking about a very, very small change in voltage. Takes us from 100% charged, 12.6 volts, to completely discharged of 11.9. What should you see? Well, you know, between 11.4 and 11.6 would be a good reading for a battery. You know, that's been sitting out all night. You know, it's been sitting there for a while. But we can't start the vehicle. You can't start the vehicle. Anyways. And then we go to this heavy load test, and this is a machine that is used, and it's hooked up. This is actually a very old school machine, but I like the picture. We hook up that. See the two big cables that come off it. There's a red and a black, and then there's the green. See that green one? That's actually an amp clamp. I'm going to show you one, although I don't have a battery testing machine. Although I'm going to run you through how to do a test like at a shop with a meter and just a simple amp clamp. Okay? Anyways, this machine puts a big heavy load on the battery, so it can actually tell how much amperage it can. Basically what we're doing is we're checking like CCA. Okay? But it's not cold, it's whatever the shop temperature is and the battery is. But we can see how many amps can be pulled out of it. And that tells us if the battery's any good or not. And that's about it. Okay? Thanks. 17 minutes. That's pretty good.